Question 8.3, I've got two dinitrobenzenes and it's asking me to determine the RF value of one of these on this chromatogram here. So what I do is I measure from the start line to the spot, and I measure from the start line to the solvent front, and I divide the smaller by the larger. So I divide the distance from the start line to the spot by the distance from the start line to the solvent front. That works out as 0.62. So the answer is D. State in general terms what determines the distance travelled by a spot in a thin layer chromatogram, in thin layer chromatography. So what is it in general terms? Well, it depends on two factors really. It depends on how well the sample dissolves in the solvent, the moving phase, the solvent rises up the plate, and how well it adheres, or a process called retention, how well it adheres or is retained to the paper, how well it sticks to the paper. The paper is not moving, so that's called the stationary phase. To obtain the chromatogram, TLC plate was held by the edges and placed in the solvent in the beaker, and a fume covered lid was replaced. Give one other practical requirement when placing the plate in the beaker. Well, the solvent depth should be below the starting line. So you can't have the solvent above the starting line. It's got to be below the starting line. Otherwise, it will dissolve any of the spots that are above the starting line. So it won't rise up and carry the spot with it. It will just dissolve the spot into the solvent. So the solvent depth should be below the starting line. The second thin layer chromatography experiment was carried out using 1,2-dinitrobenzene and 1,4-dinitrobenzene. Identical plate was used before. In this experiment, the RF value of 1,4-dinitrobenzene was found to be greater than that of 1,2-dinitrobenzene. So the 1,4-dinitrobenzene has travelled further up the plate than 1,2-dinitrobenzene. Deduce the relative polarities of 1,2-dinitrobenzene and 1,4-dinitrobenzene, and we'll explain why 1,4-dinitrobenzene has the largest RF value. So the largest RF value means it's gone further up the plate. So if it's gone further up the plate, the RF value of 1,4-dinitrobenzene is larger, so the 1,4-dinitrobenzene has gone further up the plate. If it's gone further up the plate, the 1,4-dinitrobenzene has dissolved better in the sample than the 1,2-dinitrobenzene. So if it's gone further up the plate, it means that the 1,4-dinitrobenzene is dissolved better in the solvent or the moving phase, and it's not adhered or been retained to the paper as much as the 1,2-dinitrobenzene. So this 1,4-dinitrobenzene dissolves better in the moving phase in the solvent and doesn't adhere as well to the paper as does the 1,2-dinitrobenzene. The reason that is if it doesn't adhere to the paper, it's less polar. So if something adheres to the paper, it tends to be polar. It has polar bonds within it. So the 1,4-dinitrobenzene is less polar than the 1,2-dinitrobenzene. A third thin layer chromatography experiment was carried out, and identical plate was used under the same condition. The student stated that the RF value of 1,2-dinitrobenzene in his third experiment would be greater than 1,2-dinitrobenzene. Is the student correct? So the solvent that they're using is ethyl ethanoate. Now ethanoate is an ester. It's got C double bond O bonds in there. It's got polar bonds within it. So the ethyl ethanoate is polar. Polar molecules dissolve better in polar solvents. Something that's polar bonds to something else that's polar with intermolecular dipole-dipole attractions. So polar molecules dissolve better in a polar solvent. The 1,2-dinitrobenzene, being polar, will therefore dissolve better than it did do before, because this ethyl ethanoate is polar. So dinitrobenzene is polar. So is the ethyl ethanoate. It will dissolve better than before. If it dissolves better than before, it rises further up the plate and the RF value will be larger. Therefore, the student was